they get your answer. So what's good of the decision tree? Very intuitive. Just like how we make a decision, how many options in each choice. And then you go down to what's the consequence after that. Deal with both discrete and the numerical continuous features. Discrete is very easy to deal with, but the continuous, we need to do some job, like this temperature and the humidity. If it's continuous, we're going to discretize and as high, mild, and cool. That's how, but how you do it, we're going to deal with it later. We have no assumption about the probability distribution. We just look at the cases. If you want any probability, just count. When you split it, count how many positive, how many negative. That's how you do the calculation. There's no presumption about the probability, like a normal distribution or binomial distribution. We don't have any assumption of distribution. It deals with any distribution, in another word. Of course, your case, your example should be fairly distributed to cover every case. You cannot possible to deal with a new case you never seen before. It's hard. NP hard, NP complete. That's one you are in computer science major. You know that is non-polynomial time. This is just a word to tell you. So far, we have not found a very good polynomial time to get the real optimized solution. No. What we got is a greedy algorithm, is a pseudo-optimized solution. It's what could be possible, good, but not necessarily the best. And the best because it's a combination problem. You look at the nodes and the cases and the tree and how many ways you can split. This is a combinatorics problem. That's called the curse of a combination. There's too many combinations. If you just quickly you explode it, like an exponential number. So that's why you just understand the NP hard. Algorithm are inexpensive. That's because practically we use the heuristic idea called the greedy algorithm to make it easier. We're going to deal with the overfitting problem on Wednesday. Define recursively. Basically, when you write the algorithm, you only need to write a few lines. Why? You just need to say when I stop first, baseline. When I stop to do it. And then the next, you're going to say which attribute I'm going to select to split the tree. And then you do the calculation, and then if it's not meet the stop position, you're going to do it again. That's called recursive. You just do the same thing. And easy to write, a few lines. Now, the real question is boil it down to these two. How do you select the attribute to split? Why I select the overlook to do it first, not select the humidity first? You need to answer that question. And that's how we calculate the information. That's the key. Second, that's a little bit more complicated. How we're going to start to do it? Ideally, you can either run out of attribute to split anymore. Could it be all pure? But this is ideal case. We don't do that. Most of the time, we start when it's good enough. It's good enough. You don't need to do every test to get 100. You can leave some time to do some more challenges. But what means good enough? It really depends. You are predefined the threshold. That's an experiment problem. So this is the famous example. You just keep one example and understand the one, then you go to the other. That's the strategy of learning. In this example, we got the, as you saw before, 9 years, 5 no, and with the combination of all those features. So what you do, if you look, hey, how do I going to split it? Just like I make a decision. Can I make a clear cut? If I can make a clear cut, you get F. And then I don't even consider anymore. That's easy on me, right? If I grade the paper, and then I'm going to focus my time to further ABC. My clear cut is If you miss half of your time of class F, make that decision first, then I'm going to deal with the other, right? Here has a clear cut. If it's a overcast, that means yes, okay, but the purity is very good. This is not so good, but I can do further, right? Intuitively, when you make this small, you don't need the math. You're going to figure out how you're going to split that 3 yes and 2 no. Because you still have 3 attributes here. Then you get a little bit up, then you can see the whole thing. I want you to get an intuitive understanding, then we're going to do the calculation. How are you going to do it? Think about it. 3 yes, what's in common in the 3 yes and the 2 no in here?
The wind.
The wind, you're right, because the wind is a force, then you say yes, wind is true, then you say no, right? Then you got it, that's a pure cut. And this one, can you do anything good? See, you have 3 no and 2 yes, what is humidity, right? Are you with me? See, clear cut, high, no, no more, yes, right? Then the rest, that's intuitive understanding. So why don't I use temperature as the root? Look, that's non-pure, right? And then this is better. See, that's not too bad. Oh yes, and then if you know maybe you split here, that's not necessarily bad. And that's not good. Kind of compare with this even, right? The purity.